Okay, let's move on. And the next topic is the minimum spanning tree. Minimum spanning tree. Okay, so the problem is if we have a connected undirected weighted graph like this, and how do we find a spanning tree and using the existing edges, and yet we want to minimize the total weight. Okay, so this is an undirected tree, and then this is a undirected graph, and it is also a weighted graph because for each of the edge, and then we have a value, and that is the weight of the edge. So what we are trying to do is, so the number one, we want to create a tree structure, and this tree structure should include all the nodes for sure. And the second part is, well, when we are keeping the edges as the tree edges, and we want to minimize the total weight of all the edges be kept for the tree structure. Okay, so if we have to guess, and then how do we draw draw the MST, or the minimum spanning tree? Okay, so the answer is like this. So we just keep all those edges, all the edges highlighted in the blue color, and then we will have a MST. So, well, for the MST, number one, we are reusing only the graph edges. We are not drawing any additional edges, right? And number two, we do have all the nodes connected, so we are not leaving any of the nodes behind. And the number three, well, if you add all the edges together, and then the total weight of this MST, the minimum spanning tree, is the minimal. Okay, well, we can take this one as example. So from the H to B. Okay, so if we delete this line, so if we don't want to use this line, and then, well, the problem is for the node H, it is detached from the remaining of the MST, right? And then how do we bring the H back? So if we don't want to use this edge of the with the cost of 5, and then to connect the H back to the MST, we can use this one. So H connect to A. So connecting H to A, and then the cost is 6. So 6 is higher than 5, right? So in this case, well, we can say, okay, if we don't want to use this one, and then we drop this line, and then we use this line, and then this is still a spanning tree because we have all the nodes connected. We are reusing the edges from the graph. However, it is not a MST because using this line with the weight of the 5 will minimize the total weight of the MST, right? Okay, so this is the concept of the MST. And the next part, well, in the MST, we have an important feature we want to talk about. That is the optimal substructure. Okay, so well, uh, if we want to divide this MST to two parts, and then we just say there are two trees, two subtrees, tree 1 and the tree 2. Okay, and then what we are going to do is, well, if we use this one as example, oh, that's my pen. Okay, so we are use tree 1 as the A, H, B, and C. And then we also have a tree 2 that is the G, F, E, and D. Okay, so we are dividing this MST to two smaller trees, T1 and T2. And then we can say from the T1 and the T2. And then there is a cost of 2, right? From B and E, and there is a cost of 2. And then from the H and G, so there is a cost of 14. And then from H to F, that is a cost of 10. Okay, so the point is, if we separate the tree 1 and the tree 2, or T1 and the T2, and we can see there are three possible ways to connect the T1 and T2, right? Okay, and then what do? We want to do a minimum spanning tree. So we have to pick the one with the lowest cost, and the lowest cost will be from the B to E. Okay, so if the main side is, well, if we want to divide the MST to several smaller trees, and then what we have to do is we want to find all the possible connections between the T1 and T2, and then we just pick the smallest choice. And the second question is, well, inside the T1 or inside the T2, and those edges are also the optimal. So for example, if we take the T1, okay, and then if I really hate this edge, so I want to delete that. So I don't want to use the edge between A and B. And then, well, for the T1, we will find that H, B, C, they're still connected, but A is detached. And if we don't want to use this one, and another possibility will be I can use this one. But for this one, the cost is a 6. Well, compared with 4, and then 4 is a better choice. So if we want to connect the A back to the T1, and what do we do? And then we have to pick the A to B, right? So the point is, number one, well, inside the T1 or T2, well, they are both optimal sub MST. Okay, T1 and T2, they are both optimal sub MST. And after that, between the T1 and the T2, and we want to pick the edge with the smallest weight. So we have the 2, which is B to E, and then we have the H to G, which is 14, and we have H to F, which is 10. So there are 3 ways we can connect the T1 and the T2, and then we pick the smallest value, and then this is how we can connect 2 of the optimal substructure or the optimal MST together into the optimal MST. Okay, so this is the concept of the optimal substructure. So to build the optimal MST, and then the target will be we want to build optimal sub MSTs, and then we connect them together using the lowest weight, and then we have a optimal MST. Okay, and here's another theorem. So well, if we have if we have 2 MST, say for the T1, and then for the T2, and then there are several ways that we can connect them. So if we know that for the subtree T1 and T2, and they are already optimal MST, and then we only need to pick the smallest value from the weight 1, weight 2, and weight 3, and then say if weight 3 is the smallest one, and then we just keep the T1, and then we pick the T3 because that's the smallest one to connect the T1 and T2, and then, well, we will have another optimal MST. Well, and for the T1 and the T2, they can be both sub MST, or say T1 is a very big MST and the T2 is only one node. It doesn't matter. Well, even though T1 or T2, one of them or both of them are just one simple node. It doesn't matter. This is the thinking on building the MST. Okay, so well, I'm going to pause here, and the next video we are going to see the prim algorithm. And well, usually when I'm teaching or when I'm learning the algorithms, I feel happy when I see the prim algorithm, because when I see that, and we are almost the end of the semester. Okay, so I will see you in the next video.